Tennessee's at-home learning series for math. Today's lesson is for all our 7th graders out there, though all children are welcome to tune in. This lesson is the 19th in our series. My name is Kayla Anderson, and I'm an 8th grade math teacher at Rocky Fork Middle School in the Rutherford County School District. I'm so excited to be your teacher for this lesson. Welcome to my virtual classroom. If you haven't seen any of our previous lessons, you can find them at www.tn.gov/education. That's also where you can find the student packet, which will have materials that we use in today's lesson. If you haven't seen any of our previous lessons, you can still tune in today, but it might be more fun if you first go back and watch the other lessons, since we'll be discussing material we've previously reviewed. To participate fully in today's lesson, you will need paper, pencil, a surface to write on, and the student packet. Let's get started. Today we are going to explore surface area. Let's take just a minute to review some vocabulary. Two-dimensional objects are called shapes. Rectangles, triangles, circles, squares, etc. are two-dimensional shapes. Recall that the area is the space that a two-dimensional shape occupies, or we can think of it as a measure of the surface. Three-dimensional objects are called solids. Cubes, prisms, and pyramids are examples of solids. Today we are going to discuss surface area of three-dimensional objects. Surface area is the sum of the areas of all of a solid's surfaces. We will look at the solid, which is here, and the net. Recall that if we took the solid apart and folded it out flat, that would be the net. So this is called a net. If we were to take this solid, fold it apart where it was flat, this is what it would look like. That's the net. You can see that the rectangular prism is constructed of rectangles. You can see the different rectangles here in the net. You can also see them on the solid. Rectangles form the bases and the faces. Remember that the bases of a prism are the two parallel congruent faces. The bases are here and here, or here and here on the net. So how can we find the surface area of this rectangular prism? Remember that we said the surface area is the sum of the areas of all the surfaces of a solid. So let's find the surface area of this rectangular prism. I've got it again for us here. Okay. Again, notice that this three-dimensional solid is constructed of two-dimensional shapes. So we have two-dimensional rectangles that we put together to construct this three-dimensional solid. We can find the surface area of the solid by finding the area of all the shapes that make up the solid. For this rectangular prism, all the shapes are rectangles. How do we find the area of a rectangle? Right, we find the product of the rectangle's length and width. So the area of a rectangle is equal to length times width. First, let's find the area of all faces except the bases. We call this area of the faces without the bases the lateral area. It's the area of all the faces without the bases. We sometimes use capital L to indicate lateral area. So we have two sides that are the same front and back. And then, the sum of the area of these faces minus the bases are going to be the lateral area. So the lateral area for this particular rectangular prism is going to be 2 times the area of the side, because you'll notice here that those sides are equal to one another. Sides are the same. And then we're going to add to that 2 times the area of the front / the back. So one more time to review that. Lateral area, the area of the whole thing without the bases. So 2 times the area of the side, because these sides are equal to one another. And then 2 times the area of the front and back, because the front and back are equal to one another, so we'll multiply that area by 2. So notice that for the sides, their dimensions are 20 by 8, 20 millimeters by 8 millimeters. So if we're going to find the area of one of those sides, it's going to be 20 times 8, which is 160. So to start out the first part of this, we have 2 times the 160 millimeters. The area of the side of one side is 20 times 8, which is 160. We have 2 of those. Okay. Now we need to find the area of the front and the back. So when we look at the front and the back, what are the dimensions of the front and back? Right, so one is 15. It's 15 by 20. 15 by 20. So if we multiply that 15 times 20 to find the area of one of those, we get 300. And the front and the back are equal to one another, so we're going to multiply by 2. So now multiplying first and then adding 2 times 160 is 320. 2 times 300 is 600. So the lateral area, which again is the area of the sides without the bases, is 920 square millimeters. Great. So now we need to find the area of the bases. Remember that the bases are the parallel congruent sides. We use a capital B. Switch colors here. So bases. We use a capital B to indicate the area of the base. So what are the dimensions of one of the bases of this solid? Let me go back up here where you can see. What are the dimensions of one base? Well, we can see here it's 8 by 15. So if we find the area of one base, we're going to have 8 times 15, which is 120 square millimeters. Now, keep in mind that there are 2 bases, and we will use that in just a second when we figure out the entire surface area. So now let's find the sum of all the areas to find the surface area, which we're going to indicate with a capital S. So to find the surface area, we're going to add together the lateral area plus 2 times the base. And remember that we're doing 2 times the base because there are 2 bases. So we know that the lateral area, which we found here, was 920 square millimeters, and that we have 2 times the area of the base, which was 120 square millimeters. And we'll multiply and add those together to figure out that the surface area is 1,160 square millimeters. Great work. Let's see how we can use surface area to solve a real-world problem. Aaron is making a jewelry box of wood in the shape of a rectangular prism. The jewelry box will have dimensions of 12 inches long by 15 inches wide by 6 inches high. Aaron plans to paint the exterior of the box. How many square inches will she have to paint? What is this problem asking for? Yep, it is asking us to find the surface area. I've drawn a diagram of that here. You can copy that down on your paper if you would like to. We want to identify the bases and the faces. Any pair of parallel congruent faces can be the bases. So let's choose the top and the bottom of Aaron's jewelry box to be the bases. So the top and the bottom will be the bases. So the area of one of those bases is going to be the length times the width, length times width, which is 180. Hope you got that. Okay, so the length times the width there for one base is the 12 times the 15, which is 180. And there are 2 of those. We'll use that in just a second. The area of the faces that are not bases, remember, is called the lateral area. So if we're removing these 2 bases, we have the lateral area. There are 2 faces that have an area of 15 by 6. There are 2 of those. And there are 2 faces that have an area of 12 by 6. There are 2 of those also. So if we're going to find the area of one of these, that's 15 by 6, that equals 90. Keep in mind that there are two of those. That'll come to play in just a second. And then we also have another one that is 12 by 6. And the area of that face is 72. So if we're going to find the entire surface area, we have two of the bases. Remember that the base was 12 by 15, which we multiplied here to figure out that that's 180, plus two of the faces with dimensions of 15 by 6, which we multiplied together to figure out that it was 90, plus two of the faces that have dimensions of 12 by 6, which we figured out was 72. Okay, so now we're going to continue multiplying to simplify this. 2 times 180 is 360, plus 2 times 90, which is 180, plus 2 times 72, which is 144. Going to add all three of those numbers together to get 684 square inches. So what does that mean? Yep, it means that Aaron has to paint 684 square inches of wood. All right, we have found the surface area of a rectangular prism. Now let's find the surface area of this right triangular prism. So first, let's think about the shapes that form this solid. We have two right triangular faces, which I will outline here. Two right triangular faces. Oops. Okay, and those have a base of 4 inches and a height of 3 inches. We have one rectangular face that is 5 by 11. That one I'm doing here for you in blue. 5 by 11 there. Okay. We have one rectangular face that is 4 by 11, which is here. 4 by 11. That's in yellow. And then we have one rectangular face that is 3 by 11. So that one I'm going to try to do for you in pink. I know that's a lot of overlapping colors, but maybe you can see all of those different faces there. Remember that the surface area is the sum of the area of all the faces. So let's find the area of each face. First, let's look at the triangular faces. Okay, so remember that the formula for the area of a triangle is 1/2 base times height. And we have a base here of 4 inches and a height of 3 inches. And so when we go ahead and calculate that, 4 times 3 is 12, and 1/2 times 12 is 6. But remember that that's only one of those triangles, and there are two of them. So we're going to multiply that by 2 to figure out that the area of both of those triangles is 12 square inches. Both of those triangular faces is 12 square inches. Okay? Next, let's look at the area of that rectangular face that was 11 by 5 here, 11 by 5. So to find the area of that one rectangle, remember that area is length times width. We just said that this one was 11 by 5. And so multiplying those together, we figure out that that one is 55 square inches. Okay, we have another rectangle That one was the blue rectangle. There's a yellow rectangle here, yellow rectangular face, and that one, again, we're going to do length times width. That one had a length, again, of 11 and a width of 4. So when we multiply 11 times 4, we get 44 square inches for that face. And then we do have another rectangle. And remember that the dimensions of that rectangle were 11 by 3. That's the one I tried to do in pink there. So again, we're going to use length times width. And we just said that this one was 11 by 3. 11 times 3 is 33. So that one had an area of 33 square inches. Okay, now we're going to find the sum of the areas of all of those faces. So 12 for the 2 triangles, plus 55 for one rectangle, plus 54 for another rectangle, plus 33 for that last triangle. And when we add all of those together, we should get 144 square inches. So the surface area of this right triangular prism is 144 square inches. Okay, so we've talked about solids. We said that solids are 3-dimensional and are composed of 2-dimensional shapes that we call faces and bases. We learned that the surface area of a solid is the sum of the areas of all the faces and bases. And using what we already know about areas of shapes, we found the surface area of rectangular prisms and a right triangular prism. So now we're going to do some more practice. Okay, a brand of uncooked spaghetti comes in a box that is a rectangular prism with a length of 9 inches, a width of 3 inches, and a height of 2 inches. Find the surface area of the box. Okay, so I've got a picture drawn and labeled. I'll pause for a second for you to draw that picture on your paper. In order to find the surface area, we will need to find the area of all the faces of this rectangular prism. So what shapes make up this solid? Yep, all of those faces are rectangles. Good job. So how do we find the area of a rectangle? Right, length times width. We find the product of length and width. So we're going to organize our work by finding the area of the top and bottom of the box first. So when I find the rectangles that are the top and the bottom, okay, well, we know that we're finding the area, which is length times width, but we have 2 of them. So we're going to do 2 times the length times the width. So we have 2 of them. The length is 9 and the width, is 3. And so multiplying those, 2 times 9 times 3 gives me 54 square inches. So the rectangles on the top and the bottom have an area of 54 square inches. Now we need the areas of the ends of the box. Notice that those dimensions are 3 by 2, and there are 2 of those as well. So when we look at the ends, again, we're doing 2 times the length times the width because there are 2 of them. So a length of 3 and a width of 2, vice versa. Okay, and so multiplying those together, 3 times 2 gives me 6 times 2, which is 12. So the ends of the rectangle, or the ends of the rectangular prism, have an area of 12 square inches. Okay, and then what is left? Yep, these 2 by 9 inch rectangles that we have. And again, there are 2 of those. So we'll call those the side rectangles, if that is okay. So again, the area is going to be 2 times the length times the width because there are 2 of them and they have dimensions of 2 and 9. So 2 times 9 times 2 is going to give us 36 square inches. Okay, so now that we have all the areas, let's find the surface area of the solid. So how are we going to do that? Yep, we are going to find the sum of all the area of all the faces. So the 54 plus 12 plus 36, which is going to give us 102 square inches. So the surface area for the spaghetti box is 102 square inches. Great. Let's try another one. Maybe. There we go. Okay, so what is this solid called? Yep, this is a triangular prism. We're going to find the surface area. So what should we do first? Right, we want to identify the shapes that make up the solid. So there are two triangles that have a height of 3 and a base of 8. There are two rectangles that have a length of 7 and a width of 5. And there is one rectangle with a length of 7 and a width of 8. So we need to find the areas of all the faces. You go ahead and start doing that on your paper. And in just a second, I will begin working that out here as well. Okay, so I have, for the two triangles here, the formula for the area is 1/2 base times height. The base of these triangles are 8 and the height is 3, or the base is 8 and the height is 3. So multiplying 8 times 3, I get 24, and half of 24 is 12. However, there are two of those triangles, so I want to multiply by 2 to get 24 square feet for the area of those two triangles. Did you get that? Okay, so now we need the area of these two identical rectangles. And again, that's length times width, the length being 7 and the width being 5. And so when I multiply 7 times 5, I get 35. But again, there are two identical rectangles. So I'm going to multiply that times 2 to get 70 square feet. And then we have one last rectangle that is a 7 by 8 rectangle. Okay, so I'm going to multiply here a length of 7 times a width of 8 to get 56 square feet. Okay, and then the last thing we need to do to find the surface area is to add up all the area of the faces. So 24 plus 70 plus 56, which gives me 150 square feet. So the surface area of the right triangular prism is 150 square feet. Great job, guys. We're going to do one more. Okay. So Rob is covering this box with 1 square inch tiles. How many tiles will he need to cover the box with no overlap? I'm going to pause for a second while you get started, and then I'll work in front of you here. So as you've been working, I've been writing down a few things here. So first, I divided this up into the fact that we have two 10 by 4 rectangles. We have two 3 by 4 rectangles. and we have two 10 by 3 rectangles. And so I went ahead and found the area of one of these 10 by 4 rectangles, which is 40. And then because there are two of them, I multiplied by 2. So here, again, area is length times width. And this rectangle is a 3 by 4. Multiplying that together, I get 12. But there are two of them. So those two together have an area of 24 square inches. And then for the last two rectangles, again, I'm using length times width. They are 10 by 3 rectangles. When I multiply 10 by 3 or 10 times 3, I get 30, but there are two of them, so they have a surface area of 60 square inches. The last thing that I need to do is to add all of those together to come up with my final surface area, which is 164 square inches. So this means that Rob will need 164 of the 1-inch square tiles to cover the box. Okay, so great work today, 7th grade. Today we learned how to find the surface area of rectangular prisms and right triangular prisms. You really did a great job. Here I have the independent practice, but you can also find it in the student practice for this lesson posted at www.tn.gov/education. Move that a little bit. Good luck and do your best. All right, 7th grade, I enjoyed reviewing how to solve problems with surface area with you today. Thank you for inviting me into your home. I look forward to seeing you for our next lesson in Tennessee's At Home Learning Series. Bye.